our director, Dr. A.K. Singh, to formally welcome Dr. D.P. Ray with a bouquet of flowers. Friends, in this session of horticultural sciences, there will be presentations made by the professors of the discipline of floriculture and landscape architecture, fruit science, post-harvest technology, and vegetable science. And there are total 46 theses which will be presented by the professors, out of which 24 are MSc theses and 22 are PhD theses. Again, it's a second largest school in different schools. So on behalf of PG school, I again welcome our director, Dr. A.K. Singh, that he had been there encouraging and sitting throughout the sessions. I welcome all the professors, heads of division, faculty, students, and I see the hall is almost like half filled. So we were expecting more of the students, but I'm happy that some students are there sitting at the back and cheering. So with these words, I welcome all of you to this horticulture sciences. And this is the last for this second day Convocation Week program. And I welcome once again all of you to this. Floor is open for Dr. Neera Singh. Sorry, sir. I would like to request our director, Dr. A.K. Singh, to formally introduce the chairperson of this session.
Once again, very good evening. Dr. Rasmi said that the students are present here. The students are very well organized. I was told that they have had an understanding that the school-wise they will be here. So the number is thin because those belonging to other schools, they have left. But make it sure that tomorrow it is not school-wise. Tomorrow it is for everybody, the award lectures, and they are very, very important lectures, and all of you have to be here, and the hall should be full. We will start 9:30 at sharp, so please make it sure that you are here by 9:30, okay? The first chair is a strict disciplinarian, Dr. H.S. Gupta, a former director of IARI. So I would like to see that everybody is here and the hall is full. I'm also telling this to the faculty, okay? You have seen Dr. Gupta functioning and working. At a time, he will take the attendance in the hall itself. So let us not see that kind of situation happen. It is my pleasure to welcome Professor D.P. Ray, and if I describe in one sentence, he is hallmark of simplicity. I have never ever seen a person as simple as Professor D.P. Ray in his approach in dealing with his colleagues and friends. And that is what has impressed the most about him to me. Professor Ray did his master's in horticulture and PhD degree from Calcutta University, and he served for very long at Orissa Agriculture University, Bhubaneswar, where he was professor, associate professor, head. Then he was director of research, director of extension, and also the vice chancellor of the same university. So you can imagine all possible positions except dean that he has been there in that university, and as a vice chancellor he brought a lot of transformation. He is fellow of the National Academy of Agricultural Sciences, Horticulture Society of India, National Academy of Biological Sciences, Indian Society of Vegetable Science, and Confederation of Horticulture Association of India. He has made significant contribution in the area of enhancement of fruits and plantation crop, orchard efficiency management, varietal and nutritional improvement, water management, propagation technology, high density orcharding, and feeder root distribution, post-harvest management of tropical and subtropical fruits and vegetables. We are indeed pleased to have you, sir, as someone to guide this particular session, and we look forward for your suggestions for improvement of our program, and I once again welcome you heartily. Thank you very much.
I think very good evening. This is the last session of the day, as director has mentioned, as per the program is also concerned. And you know, at the end of the day, ultimately the population becomes less. In most of the international or national seminars or whatever, you are having any discussions or any professional meetings, ultimately at the end of the day and the valedictory section, ultimately the people become less. No doubt, because it is a good thing, because my thanks to former director and also the present director, both the Dr. A.K. Singhs, and ultimately for bringing me to chair this session. And my thanks to Dean also, because he was remembering whether you are coming or not and all these things till day for yesterday also. For that reason I thank her, and also our Dr. Meera Singh to be here as a convener. And actually I am very much associated with IARI since long, because you know I have done my PhD under Dr. S.K. Mukherjee, who was the second head of the division of horticulture, and who was after this he has gone as a director Botanical Survey of India. I submitted my thesis under him on mango, and ultimately, because I am very much associated with IARI, because since long, because he was here, ultimately I was coming here for my related to my PhD work, even though he was in Calcutta, and submitted my thesis in Calcutta University. But we are the old horticulturists. During those days, horticulture is one department. In due course, the horticulture is divided into 3 and 4, and Department of Floriculture, Fruit Science, and as well as Vegetable Science, and post-harvest, and ultimately post-harvest has gone to Agriculture Engineering in due course by Dr. Alam, who was the DDG Agriculture Engineering. But we deal with the post-harvest management side by the horticulture crops, because they are very perishable in nature. But I don't want to take much time, because after the presentations, ultimately we can give some remarks. Now I think as for the program, we are having in School of Horticulture, we are having 4 divisions, 4 presentations: floriculture and landscaping, architecture, and fruit science, post-harvest technology, and vegetable science. Now I think we can start with Professor Kanwar Pal Singh to present regarding floriculture and landscape architecture, whatever the activities they have done in the institute during the current year.
Most respected Chairman of the session, Dr. Ray sir, Honorable Director IARI, Dr. A.K. Singh sir, Dean and Joint Director Education, Professor Meera Singh, Convener of the session, Head of Divisions, Professors, dear students, my dear colleagues. I am going to present the educational achievements made in the discipline of floriculture landscape architecture during the year 2019. If you see the position of the student and faculty, we are 17 scientists and 12 are research guides. And this course is being run at IHR also. So it is the position of this IHR also. Students, we have 27 and IHR 10. These are the list of contributors along with their chairman, and this is topic. There are 6 students are from IRI and 2 are from IHR. Coming to the achievements, theme 1, genetic diversity analysis and improvement of flower crops. The work was done on genetic diversity in gladulus, who worked under me, Mr. Arun. And for this, we had the 84 varieties in our germplasm. We were characterized morphologically and this molecular level. These are the traits which we took for the study as per the DUS guidelines developed by. These are the diversity in this flowers of the gladulus. So many variabilities there in flower color, which were compared with RHS color charts. These are the gynoecious and endoecium variability in gladulus. And if this see, these are corm color and size is very interesting. There is lot of variation is there in corm color. If the correlation analysis was done, you can see this flower color and this corm color. They were closely related. So one can identify or guess the color of flower what we are getting with the help of this color of corms. And in this also, this corm color was found closely related with this flower color. And this, under the species scatter diagram, again this flower color was confirmed with this corm color, were closely related. And this molecular work, again all the variety were taken, and this out of 40 SSR markers, 70 markers showed polyphorism. And these are the pictures of some markers, G5 and G7, which showed the diversity in the germ plug. And based on this study, the variety was grouped in 3 categories majorly, and 2 variety, friendship and this Victor, they were totally distinct. They were not in the group because it was having the green color. And among the silent these findings, there are positive correlation between this corm color and this flower color, and Victor and friendship variety were found diverse, and which can be used in breeding program as a diverse parent. Coming to the next study was done by Raimani at IHR Bangalore with the 3 objectives. First one was evaluation is screening gilleless for resistant fusarium wilt. Fusarium is the major problem in gilleless, and these 3 isolates they used the fog isolate, SOL and IHR1, and including the control. This is the experimental view of this experiment. And coming to the another experiment was studied on differential expression of resistant gene in different expression genotypes. And third one was validation of resistant gene expression. That these primers were used for this study. Coming to the second achievement, Cetaceous hybrid was found highly resistant, and this pink friendship was found highly susceptible among the genotypes studied. And among by using the fog, the variety was categorized in 3 groups: cluster 1, cluster 2, cluster 3, and this resistance was identified. Coming to the next theme on production aspect of the flower crops. The first crop was chrysanthemum. You know chrysanthemum is very well, it's grown for different purposes. And in pot culture, it is very much suitable because nowadays with the increase of urbanization, there is a lot of demand of these pots. So this experiment was carried out basically for pot, taking 2 varieties, this Pusa chitraksha and Pusa sona, which are very suitable for pot culture. And these are the experimental detail. And these are the treatments for the experiment we had. And this is the experimental view of this experiment. And under this, as far as the nitrogen availability is concerned, this treatment 7, they increase the available nitrogen both the varieties Pusa sona as well as this Pusa chitraksha. And in plant height was also increased by this treatment only in both the varieties. And this number of flowers are also enhanced under this treatment in both the varieties. And this flower diameter that was also enhanced. You can see the picture of the roots in tree control and this treatment, best treatment, this was enhanced volume and length of the roots. In the another Pusa chitraksha also. And as far as silent finding concerned, for getting better vegetative flower yield and vegetative growth, this treatment, Anabina and trichoderma with 2 drench and with this, with the reduction of 25% of nitrogen, it was found best. By this way, one can reduce that 25% nitrogen and more friendly, eco-friendly, they can have production of pot plant at their home. Next study was on pot culture of bougainvillea, because in bougainvillea similarly, demand of potted plant of bougainvillea is very much in the increased urbanization, and the study was carried out with these objectives, 3 objectives, and the 2 varieties were taken, Visakha and Parthasarathi, for this study. And these are the treatments. And coming to these are experimental details as per this different hormones and with different doses were used for this study. These are the experimental designs for both the experiments. These are some of the view of the experiment conducted at our bougainvillea plot. And coming to this growing media, this media coco pit, vermiculite, perlite 1:1:1 was found best for growing purpose. And with regard to this retardant, this peclobutyl 20 ppm was found best for getting the dwarf plants with flowers. And saline finding also, this for growing media, coco pit vermiculite was found best with sand and peclobutyl for as a growth retardant. Coming to the next study on marigold. In marigold, this is a petalous melistyle line. So in marigold, there are two type lines are there, a petalous and petalous. This is a petalous melistyle where no disc, no male is there, and it can be used as a melistyle for F1 hybrid supervision. And if you multiply by variety means, it is being used as a variety. In Kolkata people, what they have done, it is found in heterozygous in nature, and they are multiplying by variety and they are supplying. So whatever flower we are getting from Calcutta, that is they are multiplying by this method only. Our objective was, if you develop a male style line by the DS through DS development, what we are working upon, for that maintenance for those lines, as well as a variety, if you want to use it, how to maintain those in Delhi conditions, because in Delhi there is a harsh condition and it's very difficult to maintain throughout the year, especially in the summers. So we try to develop the protocol how to maintain and propagate the technique, as well as how to maintain the mother stock, because every 2 or 3 months we have to propagate, because otherwise in mother stock there will be flowering. So how to reduce that, how to maintain the plant mother stock in vegetative phase, so that we work on this aspect with the 3 objectives. These are the lines Arka, Agni, Arka, Bangara 2 and Vidhan Marigold 2. There are 4 lines in the country have been developed of this type. These are the details of the experiment 1. These are treatments for propagation, hormonal treatments. And these are the rooted cuttings we propagated by all the 4 varieties. And this is the effect of these hormones on rooting. And these are polytunnels we tried, which is very effective in propagation when you are putting them in the polyhouse, major polyhouse, big polyhouse. These are details of experiment 2. These are the treatment for experiment 2. This is for summer rainy. Sir, in summer or rainy, there is similar structure could work. But in winter, same structure cannot work, because in winter we require some heat. These varieties belong to Kolkata and Bangalore region. They are not surviving here in winter. That is why winter we use the polythene also in our treatments. By using this technique, we developed this, maintain this planting material in rainy season, winter season, summer season as the mother stock to get the cuttings further. And experiment 3 was evaluation of these lines for flowering purpose. After this propagation, we have to see the flower also, so that we can use them as a variety as well as a parental line. So this is the photographs of these varieties of these marigold lines during rainy season. This is winter season. As I told you, they don't belong to the temperate region. So they did not perform well during winter season. It was in summer it was little better than winter. I have come to the salient findings. Among this treatment was better for propagation, and this shade this was better for maintenance of the mother stock during rainy season and summer. And in winter we require some polythene also. And the Arka Bangara 2 was found best for this winter and summer season, or Vidhan Marigold 1 better for rainy season. Coming to the next study on glellas, on integrated nutrient management with the 2 objectives. These are the experimental details. These are the treatments, different treatments, and these are the view. Actually, work was done by Afghani student for MSc. And these are the view of the vegetative and flowering in stage of the crop, the experiment. Coming to salient findings, this experiment gave the better yield, and where we got maximum BC ratio, that is 2.19. Coming to the next study, again it was on integrated nutrient management with different other treatments, taking 2 varieties by the PhD student. These are experimental details. These are different treatments, and these are the effect of different treatments on the growth of the varieties, both the varieties. And coming to the salient findings, this 75% and this vermicompost they found best for the production, and which enhance the physiochemical and fertility status of the soil also, and signal higher status uptake was also recorded. Another study was done on this evaluation of Gallella genotype to produce disease-free material. In Gallella, there is a problem of production because it is very slow producing crop. The efforts were made to develop the technique for production of bulb through aeroponic system. Work was done at IHR Bangalore. These are the different, to minimize the occurrence of fusarium in the bulbs. Before going to this aeroponic system, they tried this treatment and of the corms. The finding was hot water treatment with carbendazim was found best for the development of disease-free corms for further study. Among the optimization of nutrient solution and evaluation genotype, for the aeroponic system, they tried 3 solutions and these 5 genotypes for this purpose, and they are the view of the experiment of this aeroponic system. These are the bulbs produced through this aeroponic system, and among the salient findings, the aeroponic solution was found better compared to the aeroponic solution 2 with respect to corm, diameter and weight, and among the varieties Arkamar was found better as compared to other for this purpose. Coming to the training, we organize different trainings as well as this guest lecture, faculty seminars and study tour during the year. And these are, as far as the placement is concerned, these are the position of our students who got PhD admission and this job. And these are papers. We had this 19 paper from 5 to 7 NAS rating and 3 paper with more than 7 NAS rating. And as I told you, we had different training. We had the lecture from Dr. R.P. Singh, guest lecture, President IAUA, and the student, they are interacting with him. And this is the pictures of study tour we had for to Kullu Manali, where the student visit the Katran Center and the center of this YS Parmar University Solan and one center of HPKV Palampur. All 3 they visited for as exposure visit. And we also had the training on Ikebana. This lady is more than 80-year-old, 82-year-old she is, and she is doing this training throughout the world. Most of the times she belongs to India. Most of the times she used to be in Germany, where her children are there. And we are fortunate that we had the training on this aspect. We also had the training of our student and SRFs in the genetics for cytological work to strengthen our breeding program. And this last year, sir, we got 3 awards as a student. Our one MS student got the IARI Merit Medal, who worked on marigold with Dr. Sapna Pamar. And another student, PhD student also got gold medal last year, who worked. And third one is my student, sir, who worked on marigold for DH development. He got IARI medal also last year, and last year he got this Jawaharlal Nehru Award for that work. This is our senior award. And I acknowledge the help and suggestion rendered by Dr. IARI and Dr. IHR Bengaluru, Dean and Joint Education IARI, and Joint Research and Extension, Head and Professor of IARI, my faculty and members and dear students. Thank you very much for patience hearing.
Thank you, Dr. K.P. Singh, for your good presentation. I think you stick to the time, thanks to you.
Okay,
Next we will go fruit sciences, Professor O.P. Avasthi. Doctor sir, you are having 18 minutes. Stick to the time. Huh?
Okay, I'll try my best.
Yes.
Respected Chair, respected Director, Dean, Convener Dr. Neera Singh, Head of the Divisions, Professors, my colleagues, and of course, and overall my dear students. A very good evening to you all. Well, I take this as a privilege to present the significant research achievements of the postgraduate school in the discipline of fruit science. Just to start with a brief introduction, these are some of the basic mandates, and most of the students, they are working as per the mandates. And as a faculty, we are 21 in number, 3 from Shimla, including 3 from Shimla, 1 from Darjeeling and 1 from NBPGR. And the total number of our students at present, they are enrolled is 42, that is 26 in PhD and 16 in MSc. And these are the students, 8 students are going to receive their degrees in PhD, and 4 students are there for MSc. And I would like to inform the House that among the PhD students, 5 students are from IAHR Bangalore and 3 students are from here discipline of fruit science, that is IARI. And these are the students who are going to receive their degree in MSc, that is 4 students here from IARI itself. And the research work has been carried out in 3 well recognized areas, that is genetical studies and molecular characterization, and these are the students who have carried out their work. And the second is on the crop improvement and character association, and the third is on the crop regulation studies. Coming to the first presentation, that is the first presentation on studies on interspecific hybridization. This was carried out by Mr. Kishore Kumar Mahanti. He studied the interspecific crossability between Mangifera indica and odorata. He carried out the molecular analysis of the interspecific hybrids and tried to create and analyze the variability in mango polyembryonic genotypes, and also carried out the molecular characterization. And these are the details of the experiment, and you can see that the number of flowers which have been crossed in the interspecific and intervarietal hybrids, and the variation which can be seen pertaining to the fruit set at different interval days after pollination. And among the intervarietal hybrids, it was considerably lower as compared to the interspecific hybrids, that is Amrapali into Mangifera odorata, and the intervarietal hybrids is of course Amrapali into Vanraj. And then validation of the parentage of the interspecific hybrids and intervarietal hybrids was carried out using molecular markers, and out of which 8 SSR markers showed polymorphism in the tested population. And some of the hybrids, they showed more than 50% of the parental allele inheritance, while 50% of were found to show maternal allele inheritance. 3 intervarietal hybrids, that is Amrapali into Vanraj 8, 9 and 16, had inherited few new alleles. In order to create a variability, the kernels of the polyembryonic, the kernels and the science of the polyembryonic varieties were treated with different doses of gamma irradiation, and the irradiation treatment significantly influenced the different physiological, morphological and physiological parameters. And we can see that the seed germination was significantly reduced at 50 gray, and including the graft success, which was considerably lower, that is 15%. Then irradiation treatments also influence the anatomical and biochemical parameters, such as reduction in stomatal density. It can be seen at higher doses of irradiation. Based on the overall study, Mr. Mohanty could conclude that the wild species Mangifera odorata had a good crossability with the cultivated mango, and this species can be used in the mango breeding program for transferring important characteristics. Likewise, variation created in peach and bappakai genotypes through gamma irradiation are useful for selecting important mutants for future use in the breeding programs. Then coming to the next presentation, in the similar line area of research, Mr. Sangma from IHR Bangalore, he studied the diversity existing in mango in 156 varieties from different regions. He characterized the genotypes, attempted the marker assisted selection, and estimated the volatiles in certain polygenies and their parents. And these are some of the genotypes, the photographs of some of the genotypes. And the salient findings of his work indicated that the cultivar Safeda, Malgova or Sora appear to be promising donors for fruit yield, while some of the cultivars like Megamu can be used as a source for shelf life of mango fruits. Likewise, cultivars Aderi, they can be used as a source for quality improvement, and principal component analysis for majorly monoterpites and sesquiterpenoids identified the maximum contributable variables of the following variables located in vector 1, that is principal component analysis 1, and vector 2, principal component analysis 2. And then Sajna, again from IHR Bangalore, she attempted the somatic embryogenesis in the polyembryonic varieties of mango, that is Valai, Colombo and Olur, and she aimed to optimize the protocol for somatic embryogenesis and planned regeneration by using nissless tissue in selected polyembryonic mango cultivars, that is Valai, Colombo and Olur. And she assessed the feasibility of somatic embryogenesis and planned regeneration from immature zygotic embryos, and confirmed maternal or zygotic origin of the embryonic cultures using molecular markers. And these are the source of explant was ovule with intact nucleus and zygotic embryo. From her study, Sajana, she found that the best combination for induction and proliferation of callus from nucleus tissue was 2,4-D and GA3 at the rate of 5 milligram per liter and sucrose 50 gram per liter, whereas coconut water alone and in combination with casein hydrolysine was found better for proliferation, conversion and maturation of somatic embryos from zygotic and nucleus tissues respectively. And then further AB at 0.01 milligram along with PEG 100 mg per liter was found to be the best concentration for maturation of somatic embryos. Then Anjali Sori, again from the discipline of fruit science, IARI, she studied the genetic improvement in citrus using in vitro approaches, and her objective was to enhance the hybrid seedling recovery using in vitro embryo discovery in polyembryonic citrus species to standardize the technique for production of tetraploids and the protocol for hardening in vitro raised plantlets. And these are some of the crosses which were used, that is female parent and male parent, that included the edible citrus fruits and the non-edible citrus fruits, and these were the culture media, that is B5 media, malt extracts, and also the biological hardening media. These were the hardening media which were tried at the later stages. And these are the photographs. And the salient findings of the work of Anjali suggests that in the acid group 100% embryo germination was recorded in the younger embryos, that is Pusa Udita and Kagji Kalan, while older embryos give higher germination in acid lime collection 2 into Kagji Kalan, and B5 media malt extracts plus GA3 was found promising for high germination and planned growth of embryos rescued from sour orange into succaten and sour orange into Troyes ranges. Then further B5 media and malt extract could be better for higher germination and planted growth of rescued embryos from the crosses of lime into lemon. And she also concluded that the embryos could be rescued up to 190 to 200 days. This is an important findings, days after pollination into Cleopatra mandarin into Troyes range and into succaten into sour orange crosses, succaten crosses. Then Sandeep, he studied the effect of composition on culture media and explant type on in vitro organogenesis of citrus hybrids using mature tissue, and also standardized the in vitro protocol for rapid multiplication of citrus hybrids using the mature tissues. And these are the details, the experimental details. The 2 hybrid stocks were used, that is 20-2/15 and 18-2/15, and these were the basal cultural media which were reduced, and these are the supplemented media. And the salient findings of Sandeep, it showed that in general DKW and MT media proved to be a better basic culture of media for rootstock hybrids 20-2/15 and 18-2/15, and adding 2IP, that is a source of cytokinin alone could not modify bud proliferation, regeneration and growth of regenerated explants, but when added with NAA and GA3 yielded the beneficial effects. Then coming to again the presentation of Jagdisha, he is a student from IHR Bangalore. He worked on wide hybridization and qualchiplied studies in guava and attempted the crossability among the various species of guava, tried a ploidy manipulation using colchicine and studied the variability in the resulted progenies from certain seedling characters. And these were the species, the 4 species where we used in his study. And from the findings of Jagdisha, he suggested that the Pseudium chinensis and Pseudium guineensis were found to be good cross compatible among the male parents, while Allahabad Safeda and Arka Kiran were found to be a good cross compatible among the female parents, and stigma maceration technique helped in overcoming the crossing in competitive barriers. Then ploidy manipulation using colchicine, he found that the maximum tetraploids were generated when the seeds were treated with 0.8% collagen plus 200 ppm GA3, while the seedling management treatment with 1.5% colchicine generated the maximum mixaploids. Then coming to the MSc presentation in a second area of research, that is crop improvement and character association, Megha, she studied the variation in fruit quality parameters of 16 mango genotypes. She profiled the contrasting manogenotypes for fruit sugars and phenol, and also identified polymorphic SSRs between Amrapali and sensation, parental genotypes, and their validation in the hybrid progenies. And these are the details of the experiment she followed. And the findings of Megha, it suggests that she recorded a maximum phenol content in cultivar Langra and the minimum in Dashahari. And out of the 50 new hyper-variable SSR screened against parental mango genotypes, Amrapali and cessation, 11 HMSSRs. In fact, these 11 HMSSRs, these are the SSRs which has been generated by Professor N.K. Singh, and they were found to be polymorphic, and out of which 7 were used to ascertain the hybridity of the progenies. Then Tanushri, she conducted a research work on effect of chemical elicitors, that is methyl jasmonate, and BTH, that is benzothiazolinone, on the physico-chemical quality of cultivar Pusa navrang. Besides attempting the morphological and physiological characters, she studied the effect of chemical elicitors on the phenolic flavonoids and anthocyanins in grapes, and also studied the effect of chemical elicitors on induced antioxidant enzymes in cultivar Pusa navrang. And these were the treatment details, that is different concentration of methyl jasmonate and BTH at different days of at different growth stages and the days interval. And from her finding, she found that 10 millimole of methyl jasmonate concentration when applied at virigen stage, and 0.4 millimole BTH when applied, this also when applied at virigen stage, enhanced the anthocyanin content, phenolics, flavonoid content in grape cultivar Pusa navrang, while application of 0.4 millimole BTH at virigen stage enhanced the antioxidant activity. And then coming again to the MSc presentation, that is Nitin from our division only here in discipline of fruit science. He determined the influence of interspecific hybrid grape root stocks on growth physiological and biochemical parameters of grape cultivar Syrah, and also studied the impact of interspecific hybrid grape root stocks on fruit yield and berry quality. And these were the 7 root stocks which were studied, and these were the parents which has been used for in the experimentation. And based on the findings, Mr. Nitin, he found that the Syrah on rootstock P1103 ripened the earliest, producing quality fruits, higher yield, inducing total phenols and flavonoids, and this also give an indication that this particular, due to the increase in the phenols and flavonoids, this can be a better source for the resistance to the biotic and the abiotic stresses. And fruits on rootstock 14B, they registered a higher juice recovery percentage, while rootstock SO4 induced longer, all the morphological characters were found to be better on the rootstock 4, and they also mobilized the uptake of the phosphorus and zinc along with the highest peroxidase activity in cultivar Syrah. And then Nikhil, also an MSc student, he carried out the morphological, biochemical and molecular characterization of guava, and he characterized the guava hybrids, and also he tried to characterize them using the molecular markers. And these were the details of the parents which were used, the hybrids, and these are the genotypes which were used for this study. And from the findings, Nikhil, he could conclude that among the various guava hybrids evaluated, that is GH 2018, 2018, 1, 2 and 8 were found to be superior in terms of morphological and physiobiochemical parameters, and they also can be used as indices for the further evaluation in the further evaluation programs. And out of the 25 SSS markers tested, 9 were observed to be polymorphic, which can be used for screening of guava hybrids, and out of these 19, 2 were further found to be very promising. And Shaili, again from IARI Bangalore, she studied the genetic diversity and characterization studies in mango, attempted the morphological, biochemical and molecular characterization, estimated the population structure in pomegranate germplasm, and estimated the genetic varicity between and within the population and hybrid progenies derived between Bhagwa, double flower and Nana. And these are the details of the experiment. 54 pomegranate germplasm progenies, including parents of Bhagwa, double flower and Nana, were studied. And from our findings, it was shown that the genotype number 119 was found to be highly heterozygous among all the genotypes, and the genetic distance was highest between the genotypes mutant, that is 1/1, and the wild type, that is 318699, and the highest peak was observed for primary SSR 20, that is 0.975. And the last research work was in this field was on the that is on the crop regulation, that was carried out by Subhash Chandra. Subhash Chandra, he studied the crop regulations and sourcing studies, relation studies in Annona, that is Annona squamata, cultivars Arka, Shahan and Balanagar, and he in fact he tried to standardize the training and the pruning techniques, and based on that On his observation, he could recommend that fruiting can be advanced by 8 to 9 weeks with pruning treatment, that is 75% pruning, and further with the use of urea at the rate of 10% and 15%, as well as concentration of erythritol. They were found to be effective defoliatant for advancing fruit in sugar apple, that is cultivar Balanagar. Then these are some of the awards and honors. A couple of awards were backed by the division, like the HSI award by Ghosh by Young Scientist Award. Then Dr. V.B. Patel also, he got the HSIDP Ghosh Young Scientist Award for this year. Madhubala Thakre. Then Dr. R.M. Sharma, he got the fellow for the Indian Society of Horticulture Research. Myself, Dr. Verma and others, they got the Indian Society, fellow of the Indian Society of Horticulture Research and Development Uttarakhand Award. That is the fellow. And so some of the awards were also conferred upon by our students, like Sri Ram Chandra. He is going for an international training in the area of biotechnology at Department of Horticulture, University of Wisconsin, USA. And just day after tomorrow, he will be leaving for USA. And then Preeti Singh, she bagged the Best Poster Award on evaluation of heterosis in papaya in the Indian Horticulture Congress. Then she also got a National Fellowship for OBC. Then Reena Pusti and Thevyani, they got the Best Oral Presentation Award in a national seminar organized by the College of Horticulture and Forestry, Jhalawar, Rajasthan. And besides this, extracurricular activities such as study tour was taken to Himachal Pradesh by the students, and all the students from vegetable, floriculture and fruit science, they went together to Himachal Pradesh, and they participated in national seminars and conferences, and debate was also organized on the challenges of confronting the fruit production. And besides, some of the students were also engaged in the extracurricular activities such as Rangoli, quiz competition, like Napika is there, Kuldeep, Shweta, Narendra Singh, they also got the prize on the different occasions. And these are the, so far as the employment profile is concerned, it has not been very encouraging, because no post has been advertised by the ASRB for the last 4 years, and compelled by the circumstances, the students have no option but to go for the other jobs like Deputy Superintendent of Police, then Section Horticulture Officer in Horticulture, then of course one Assistant Professor in Sri University, Tanushri, but that too also is on an ad hoc basis, and of course 4 were admitted in IARI. And before, these were some of the facilities which were created in the division. And before I conclude, I would like to thank the past director, the present director, Dean, Dr. Neera Singh, my friends, and of course the students for their patience hearing. Thank you very much.
Thank you, Dr. Avasthi, very good presentation, and it is good work is done by the students for their MSc and PhD work. Thank you, Doctor.
Thank you.
Now I request Professor S.K. Jha to speak on post-harvest technology. Doctor Sahib, we are having 15 minutes.
Right, sir. Good evening, respected chairman of the session, Director IARI, convener Dr. Singh, heads of the divisions, professors, and my dear students. It's a proud privilege to be here and to present the findings of 11 students who will receive degree this year. These are the students who will receive degree. There are 7 master students and 4 PhD students. Their current status that 4 of the MSc students have joined as a PhD scholar here. Then 2 Myanmar students have gone back and have joined one of the Indo-Myanmar project that has been initiated by Government of India. So they are contributing there. Then 1 student from Afghanistan has gone back, and 4 PhD students who will receive degree. 3 are ARS scientists and 1 is horticulture officer. Then these are the 3 areas where our students have worked. Number 1, processing of horticultural crops, where 4 theses, processing of edible crops, 1 thesis, and in post-harvest management of horticultural crops, 6 theses. I will start with one top crop, that is onion. And in onion, Mr. Sumit Urhe, under my guidance, has worked on development of roasted onion flakes. Here, this is some slightly different from drying, because Moisture is reduced here also from 85% to 2 to 3%, but in the process, a texturization, that means developing a crunchy texture was the idea in this. So two heating methods have been used. One is convective heating method and another is volumetric heating method, and in two ways. One is single step process and two stage process. In single stage process, in both heating method, it has been directly reduced by continuous heat exposure, and in two stage process, first the moisture has been reduced through convective system up to 20, 25 and 30%, and then to by volumetric heating system to 2 to 3%. Then the result suggests that in convective drying system, the time of drying took 2.25 to 6.25 hours, and one of the important parameters for onion is its pungency. So when you go for high temperature, pungency reduces drastically. If you go for long time, pungency reduces drastically. So we have gone for two-stage system, and we found that in two-stage system we could develop texture and we could also reduce the time to a significant level. And we also tested 5 varieties, that is Pusa white round, Pusa white flat, Pusa red, Pusa Sobha and Pusa Riddhi. And out of these 5, Pusa white round and Pusa white flakes performed better in terms of developing roasted onion flakes. Second thesis by Harish under the guidance of Dr. Salini worked on development of vinegar using cantaloupe and falsa. Here the student tried to work on develop different blends, and here it is shown how the method, how the pulp has been extracted, then juice has been extracted, then blending, then inoculation with Saccharomyces cerevisiae, again then inoculation with Acetobacter aceti, and then finally with centrifugation the vinegar has been obtained. So the blend composition was found to have very significant effect, and found that the results suggested that 60% falsa and 40% cantaloupe favored high acetic acid, and it also met the commercial standard, which requires that 4.5% of acetic acid should be there. So that was found in this combination, and the sensory acceptability was rated very high. Out of 9, it was scored 8.7. The third thesis, Ajit Kumar Singh, under the guidance of Dr. Vidyaram Sagar, our head of the division, he worked on development of anthocyanin-rich nectar. And here he used two fruits, guava, Allahabad Safeda, and colored grape, Pusa Navrang. And again, he also worked on different blend composition. What you can see, it is shown here, the blend composition of guava and this Pusa Navrang. And pasteurization treatment by gamma irradiation, microwave and thermal treatment, these 3 were compared. And then packaging, in 2 packaging materials are used for transparent glass bottle and amber colored bottle, and storage condition under ambient and refrigerated condition. And the results suggested that microwave pasteurization was found to be the best treatment for pasteurization of this nectar, and 50-50 blend of guava and this navrang gave the best acceptable quality of nectar, and both microwave and thermal pasteurized blended nectar remained safe under refrigerated condition for up to 4 months. So the fourth one, PhD thesis, Jyoti P. Dhakne, worked under the guidance of Dr. Abhijit Kar, and she worked on concentric encapsulation of lycopene. And lycopene has been extracted from 2 sources, that is papaya and grapefruit, using supercritical fluid extraction, followed by encapsulation of extracted lycopene using oil rich in gamma fatty acid, that is rice bran oil, that has been used, and here high pressure homogenization technique has been used. Then encapsulation of encapsulated lycopene, and further then storage stability has been studied. So here grapefruit, that is red blush, and papaya, red lady, has been used in this study. And supercritical fluid extraction technique, the effect of pressure in this range, temperature 55 to 85 and time 60 to 2 minutes has been studied through response surface methodology. Then here two co-solvent has been used, in one case ethanol and in one case rice bran oil. When ethanol has been used, it is a three-step process. It has been followed by high pressure homogenization, and again this process has been standardized, and three parameters have been considered: homogenization pressure, number of pass, and emulsifier concentration. And when the rice bran oil has been used, then it is a two-step process. It has been simply taken for spray drying, and wall material in both cases has been used, that soya protein concentrate and whey protein concentrate, along with jackfruit seed polysaccharide and tapioca polysaccharide. Then the encapsulated material has been tested for in vitro release kinetics, and then a storage study under accelerated condition has been studied. The results shown here: the optimum extraction condition of lycopene from grapefruit and papaya, through response surface methodology, it has been found out, optimized. The lycopene content in both have been found out. This one, gamma original retention, has been found in the range of 96 to 97%, and the extraction efficiency has varied from 70 to 80%. Then for high pressure homogenization conditions have also been optimized, and encapsulation of lycopene and gamma fatty acid using combination of these protein polysaccharide has resulted into lycopene retention of 89%, 89 to 97%, and gamma original retention of 91 to 99%, and antioxidant activity of 61 to 498 micromole Trolox equivalent. And release kinetics suggested that 48 to 72% release of gamma original and 44 to 69% release of lycopene occurred in 8 hours time period. That means very slow release took place in different pH conditions, and accelerated storage study suggested retention of 96% gamma original and 89% in three-step process. So means we can see what we anticipated, hypothesized, we have been able to release. And this accelerated studies of 7 days means in normal storage it will be equivalent to 6 months of storage. So it will remain safe and retain all the antioxidant properties. The fourth, that is processing of edible crops, Sandeep Davange, under my guidance, worked on development of breakfast cereal using corn, and two techniques have been used. One is through your grits, and grits is a product of dry milling of maize. So through dry milling, this grits has been prepared, then it has been converted into flakes. And another is from flour, converted into flour, and flour is through extrusion process. This is converted into pellets, and then pellet is converted. So you can compare and see that there is very good uniformity in this when you go through extrusion process. So here when you make through grits, then this is the technique that soaking has been in a systematic manner studied, then steaming, heat treatment, flaking, and roasting. And in case of flour, the different studies that influence of particle size on the pellet quality, then gelatinization, whether gelatinization influences. So gelatinization has also been achieved through two ways. One is that convert into flour first and try to gelatinize the flour, or gelatinize the whole grain, then you convert it into flour. Then influence of extrusion parameters on pellet making quality. And pellet, when we say, obviously we look for high ductile property, that material must get ductility property, and ductility property means large force and large deformation should come. So that has been studied. Then heat treatment, and followed by flaking and roasting treatments. Then the salient findings, we have been able to standardize the flake making properties, operations, soaking of grits at pressure for 2 hours in 8% sucrose solution, steaming, then heats for 3.5 minutes, then flaking in 2 pass, and roasting at 300 degrees centigrade to bring the moisture content to the level of 3 to 4%, as well as to have a crispness in the product. Then for flour, that we have found that composite flour gave a better quality pellets than pre-gelatinized flour gave better quality pellets, and the extrusion condition for making good quality pellets with a good ductility property was found, and then two-stage flaking also, not in single stage. We generally compress it under a roller mill. So in two-stage it gave a better quality of flakes. Then storage study was in a flexible packaging studied, and we found that up to 6 months there was no initiation of deteriorative changes. So it was perfectly fine. The shelf life could be even longer than 6 months, but due to time constraint it was stopped there. Then the changes in quality parameters was again modeled, and we found that zero order kinetics followed that reaction. Then next 6 thesis I am going to present on post-harvest management, and first I start with mango. Here the influence of polyembryonic root stock has been studied, whether the root stock affects the storage life of the fruit. So 3 root stock has been used, K5, Olur and Kudakkan, and 2 varieties of mango has been used, Amrapali and Arunima, and we found that Arunima had a shelf life of 12 days at 12 degrees centigrade, and Amrapali had shelf life of 9 days, and the root stock Olur showed a significant influence on fruit quality, on storage life. Then second, MMO, she worked under the guidance of Dr. R.R. Sharma, and she evaluated 20 genotypes of mango, and she characterized the various biochemical characteristics of all 20 genotypes and shelf life of these. Most of the genotypes had shelf life of 6 days, but Arunima, Amrapali, Shrest had 9 days, and Arunima had 20 days of shelf life. Matsumon, she worked on post-harvest regulation of senescence and decay in banana. She used 2 different treatments. One is hot water treatment followed by calcium lactate treatment, and another was hydrogen sulfide treatment. And the results displayed that hot water treatment with calcium lactate extended the shelf life up to 9 days, which was extension of 2 days over the control, and 1.5 mm hydrogen sulfide treatment gave better influence in terms of extension of post-harvest life, and especially sugary spot, which is a major problem in banana, that was effectively controlled by this treatment. Then Ziaullah Sulaiman Khil worked on hexanal treatment for enhancing storage life of apple. The apple he used was Royal Delicious, and he used pre-storage treatment of hexanal and post-storage treatment of hexanal, and in 2 forms, dip treatment and the vapor treatment. And the result suggested that 0.101% hexanal applied as dip treatment for 3 minutes extended the life up to 3 months at 1 to 2 degrees centigrade temperature. In vapor form also, it gave equivalent result in terms of at the rate of 360 microliter per kg for 2 hours. And post-storage, this was pre-storage, post-storage when you bring out from the low temperature, then 0.03% for 3 minutes, it extended up to 21 days. And cost economics also was found out, where we found that if you give this treatment, then BC ratio 6.95. Then Avon Yanthan, he worked on senescence regulation and value addition of sweet pepper under the guidance of Dr. V.R. Sagar. He gave different treatments of salicylic acid of very different variants, and also surface coating by chitosan and the carrageenan, and then drying treatment, water blanching and different drying treatments. And the results suggested that salicylic acid treatment with acetyl salicylic acid at 1 millimolar gave the best influence, and extended the shelf life up to 9 days, and which was 3 days extension in compared to control. And also chitosan treatment gave better treatment in Swarna, especially out of 3 varieties. And steam blanching followed by vacuum dehydration gave best result in the dehydrated products. And for 1 minute more, I will take the last thesis. This is Gajanan Gundewadi under the guidance of Dr. Salini. He worked on development of nano composite fibers, what you can see here, and the effect of this nanofiber on the shelf life of sapota fruit was studied. So for development of nanofiber, these are the parameters that were varied, that is polyvinyl alcohol, beta cyclodextrin, PDCl2, thyme and betel oil, and it has been characterized by SEM, XRD and encapsulation efficiency, and its in vitro and in vivo antimicrobial efficacy has also been found out. And the results suggested that palladium chloride was more effective in terms of ethylene scavenging capacity compared to potassium permanganate. Then the electrospinning technique has been standardized for making nanofibers, and this is the condition for that. And nano composite fiber with 3% palladium chloride had ethylene scavenging capacity of 615 ppm. And this thyme and betel leaf oil at 1:1 ratio gave very good antimicrobial property to this nanofiber. And then we also found out that in package placement of this nano fiber extended the fruit life by 2 days at ambient condition, which can be considered as very good. And in vivo study of sapota fruit inoculated with this revealed the effectiveness of this nanofiber in reducing the decay incidence by 80%. Then this is Jyoti Nisad, who got Best Student of the Year award last year, and continuing student who has gone on by taking relief. One joined, one ARS, one assistant engineer, then 2 horticulture officer. These are the students who participated in extracurricular activities. We had 25 publications from student thesis this year, out of which 18 are more than 6 rated and 2 are more than 9. And just one, that our faculty is also associated with this Indo-Myanmar Care project at Myanmar, and first batch consisting of 6 MSc students passed this year. So our faculty has made a very good contribution in this by teaching, by guiding, and this is first program food related. There is no program in Myanmar so far, so this is a good beginning under Indo-Myanmar project. Thank you. Thank you so much. All the contributing students, their advisory committee.
Thank you, Dr. Jha. All right,
you, sir.
Good presentation. Many, many thanks. I think now next I request Dr. Professor T.K. Behera to present on the vegetable science. I think 20 minutes is there.
Okay, I am the last batsman, I think, in this today's day. Most respected Dr. D.P. Rai, my teacher in the OAOT Bhubaneswar, Dr. A.K. Singh, Director, and Dr. Madam Dean, and Dr. Nida Singh, and professors and head of the divisions, students and faculty members. I am going to present this from the Division of Vegetable Science, the achievements of the students, as it is mandate and thrust areas is there, and we are also impart postgraduate teaching education and training to the human resources, particularly for the students. This year we have about 21 faculty members who are recently joined, and then degree awards, there is 6 PhD and MSc 9, and we have just the theme areas, the mapping and training of genes for and molecular breeding, genetic studies, heterosis breeding, interspecific habitations, and storage quality in different crops. PhD students, we have IARI as 2 PhD students, and both are in service students, and they are in the split PhD students, and one in Indian Forest Service is joined, another in air scientist, and mostly all of them those working in this off campus of IARI, that is IS, ICR, IHR, they are also working in the different private seed companies. The students also MSc, this already all the students has been in the PhDs, they are doing work in this IARI itself. And if you see the first work, that is in studies in the CMS system hybrid development in the validations of molecular markers linked to the fertility restorer genes in capsicum annum. As you know, that is Chile, and the capsicum program is also there in IHR Bangalore, also in IARI. So in this case also it is a problem in this case of getting the stable CMS system in case of capsicum annum, particular sweet paper. But in the Chile it is already been established stability there. So in that case we have taken some of the germplasms from the exotic germplasms which are utilized for the CMS lines of the hybrid development in this case of capsicum and annum, that is in sweet paper. We passed the stability of the CMS lines in the low temperature conditions. They identify the maternal and the fertility restorer genes, particularly in the CMS lines. Also study the effect of the CMS system in the yield and yield attribute traits. Also the validations of the markers, particularly for the male sterility and fertility restorer genes. We have also here studied in this particular thesis. So we studied that different combinations with respect to this anthodiesins, and also score them, the pollen fertility levels, also pollen productions, then score them, then pollen staining results, and you have to find that some of the things they are having this no pollen, that high stable, no significant number of viable pollens in the recorded. In few pollens where they are seen in some of the viable productions also there, which is also the maternal lines have mentioned, and the fertile high level of viable pollens which is only the fertile lines they have mentioned. So in this result they have found that CMS lines is fertile pollen is observed, and in maternal lines many fertile pollens were observed to the pollen germinations, and according to all the maternal lines they have found it out here. All the 5 CMS lines found which is got it from the outside are both in perform well in the both in the field conditions as well as the polyhouse condition. So they just CMS system, and then they found this maternal lines and the fertility restorer genes with respect to the CMS systems which borrowed from these other countries. And you have based on this pollen fertility level, that is 0 to 1%, which is categorized as a perfect maternal line, and 1 to 50% there is a partial maternal line, and for 50 to 80% or more there is a partial restorer lines, and more than 80% which is called the perfect restorer lines. So they have on that basis they have classified all the maternal and fertility restorer lines in case of capsicum. They also validate the molecular markers linked to the male sterile lines, and particularly for this ATP scar genes which is found in case of this male sterile lines. Also they validate the markers for the restorer fertility line which is already recorded, already reported in the case of capsicum. Another students work in the that is Yogesh, is work on the genetics in the yield and IBM resistance in okra, particularly to study the genetics of yield and related traits in okra, and to study the genetics of yellow mosaic virus resistance in okra and the crossability relations with these okra germplasms, particularly for the interspecific hybridations he did it. First and foremost work is did in the reactions to the genotypes with the IBM resistance, and also found that some of the lines which really give a very good result with respect to IBM resistance is concerned, and DOB12 and DOB66 and DOB92, which is having even after 90 days of this in the field conditions, they are giving resistance to this particular virus. Then reaction to the segregating populations also they have studied, with particularly for the genetics of this one, and they have segregated to the more susceptible one, the susceptible, highly susceptible, and the moderately susceptible in the one group, and resistance in the another group, and they have found that this is also governed by the single dominant genes in respect to the IBM resistance. He also have the crossable studies work with this Esculentum and Tetraphilus, crossable with respect to this Acali, and also Esculentum with this Mostatus, and they have found the different crossing efficiency. Based on that, they have performed the different process, which is 0.84% with respect to Esculentus and Tetraphilus, and 1.59 in case of the Acali and Esculentus, and 0.6 crossability efficiencies found in the Abelanus Mostatus as well as Esculentus. And these are also based on the seed germination percentage, which is also further multiplied all the different segregating generations. And these are the advanced populations also developed, which is having from the wild okra derivatives from the Esculentus group, with from the Tetraphilus, from Cali, and also from the Mostatus. Another students working on the particularly from the IHR, he is working on the marker-state breeding incorporating combined resistance to lead blight as well as tomato leaf curl virus resistance in tomato. He got this IARI merit medal as a study. He has presented this one. And he identified some of the additional stable sources of resistance to lead blight as well as the tomato leaf curl resistance. It is the first report that he has pyramided the genes both in the lead blight resistance as well in the in case of the tomato leaf curl virus itself. So validations of the molecular markers linked to the both lead blight and tomato leaf curl virus disease in tomato lines, and then developed the pre-breeding lines F1 hybrids with combined both the resistance are there in these hybrid combinations. So this is the scheme what he has tried with this developing the pyramidal lines TY2 and TY3, PH1 and PH3 both for the lead blight resistance, and combined resistance also found in the double crosses, where he also having this marker-state breeding by which he can also confirm this both tomato leaf curl resistance genes, that is TY2 and TY3, and combined with this PH2 and PH3, and there are about 7 pyramidal lines they already developed, which is utilized for the hybrid productions in case of tomato. They have also validated the markers validation programs. Also, they have seen the whole plant assay in the all the populations here. Also, they have also confirmed with the detached leaf method assay for the lead blight resistance. Also, responsive they have found out the response of pyramidal lines with genotypes against the phytophthora infestans, the lead blight resistance, as well as with respect to the tomato leaf curl viruses. In this case also in the 7 lines, and they have found the horticultural traits, and based on the horticultural traits also they have evaluated some of the hybrids, which is combinations of the TY2, TY3, PH1 and PH3, and all of them, and we utilized for their program, and they have developed the good hybrids in case of tomato, and out of which Orca is one of them. And also they have newly hybrid they have developed, which is called as Orca Aved, which having disease resistant to 7 diseases in this particular hybrids in case of IHR Bangalore. The IHR also another students, Devin Burma, he is working on this heat stress, particularly in case of garden pea, and also he is having lot of germplasms. He has screened in this for the high temperature tolerance. Also to identify the traits associated with the high temperature in case of garden pea. Also study the inheritance of these traits in compare the resistance to the high temperature. So he has seen that Azad P1 seedlings used for the standardization of the lethal dose, which is about 43 degrees Celsius at 3 hours. And the optimum dose inductions will be 30 to 38 degree Celsius for the 3 hours. And in this case, they have also evaluated 32 genotypes of this garden pea, which can also be in heat temperature stress conditions. And the tolerant is having Orca Uttam and some of these lines, and also some of the times in intermediate type, and some of these are in susceptible types. And all of them has been in this screen high temperature using the temperature induction response technique. These are the susceptible and versus the tolerant lines, and what in case of high temperature conditions, there is no pod filling will be there in case of this one, and also there is drying of the plants, and in case of this, those are high temperature tolerant types, they have seen the totally variance, different type of genotypes with respect to this high temperature tolerant is concerned. And also they found out some of the physiological parameters like mammal stability index, chlorophyll stability index, pollen viability germinations, stomatal density, stomatal size, net consistency, everything they have found out there. And they have also genetically analyzed that the tolerance to high temperature showed a polygenic inheritance for the traits used in the different cross combinations, and interesting effects also they found in different magnitudes. Another students in IARI, they worked on IHR, sorry, they worked also on the resistance to the bacterial with resistance, particularly for screening of the available germplasms to identify the stable resistance sources in case of bacterial resistance, and hybrids development also studied with the evaluations of yield traits and the horticulture traits to work out also genetics for the resistance to bacterial wilt and identify the molecular markers linked to the bacterial wilt. The result says some of the lines like carry 1, that is from the Port Blair, they have taken some of the lines which is totally immune to the bacterial resistance, as well as Surya and WCGR, which is IHR3 and S57, which are resistant to bacterial wilt, whereas one of the genotypes, that is Rampur, local, and IHR 586 are highly susceptible to this particular bacterial wilt disease. Among these F1 hybrids also they have found some of the best combiner for yield and other traits. Also their resistance to the bacterial resistance, and they found there is single dominant genes which is conferring resistance to this particular cross of carry 1 and Surya can be used for the bacterial resistance for the further crop improvement program in brinjal. Also they identify this SSR scar marker which is highly linked to this bacterial resistance in case of brinjal. And the students from IHR also work on chili. So they have very good program in the chili breeding program, which they have identified the stable source of resistance in the chili leaf curl viruses in capsicum species. screening of white root resistance in capsicum. Also, they study the effect of viruses for biochemical changes in the host and behavior changes in the factors, genetics of inheritance of these viruses, resistance in chili, and identification of molecular markers linked to this resistance, particularly for the chili leaf curl viruses. Those screened both in the field conditions, and they have taken about 239 genotypes, particularly for the screening both in the field conditions and individual cage inoculations, and they found some of the genotypes which is really giving this resistance to these chili leaf curl viruses. And they have seen the molecular characteristics, the viruses also. And out of 239 genotypes, the PDA ranges from 0 to 100%, whereas DSA ranges from the 0 to 90%. And IHR 4591, which is a species Solanum pseudocapsicum, which is immune to the chili leaf curl viruses, whereas IHR 4615 and IHR 4630 and 43476 denote to be highly resistant, which are utilized for their crossing program. They also screened them against the virus, against the vectors, which is white fly, and about 125 capsicum genotypes they screen it, and total phenols, the pheboloids and other compounds they have found it from in the different species and the genotypes, which is also giving favorable to the resistance, giving resistance to this white fly in the screening methods. So they found that some of the lines like IHR 43300 and IHR 4338, which showed the good tolerance to this particular. And like in the other crops, there are some of the physical barriers, particularly granular trichromes density, cuticle thickness, and which is negatively related to the white fly population. Infected plant volatiles like methyl, eugenol, and 3,4,5, and some of the other chemicals like isomelicins are also found to responsible to attract the non-viruliferous insects. They have also studied the genetics of the chili leaf curl resistance in case of using the resistant paired IHR 4517 and 4615, and they found that these genetics analysis that indicated the single dominant genes Indians for the chili leaf curl viruses, both in resistant parents also study. In IARI also, our group also studied the same phenomena with respect to this chili leaf curl virus resistance in case of chili. In onion, one MSc students work and particularly for the different Kharif onion, particularly to evaluate onion genotypes to yield-related traits for biochemical during Kharif onion, because Kharif onion is not cultivated mostly in case of in the northern part. So they have screened out some of the materials for the Kharif onion productions in the northern belt, and they screen that onion genotypes against the purple blotch, which is severe disease in case of onion, which is through the artificial inoculation system. And also they grouped in the 3 group, and based on that quality parameters as well as the yield parameters, they grouped in the 3, these are in the cluster in the 3 groups, and based on this particular cluster 3, which is contain high TSS as well as TSS, and the cluster 2 they contain the high bulb weight of this particular. In the cluster 3, mostly this some of the antioxidants are also more in this particular genotypes. And they also screened some of the lines I already told about this purple blotch, and out of which only one which is showing the resistance, that is Pusa somia, and some of the some of them are having highly moderately susceptible, then some are highly susceptible, and mostly these are Pusa somia that can be utilized for our breeding program, particularly for this. Another students work in this K-base in Brassica oleracea capitata using double haploid lines, and which is also very significant work done in this Cartine station. The diverse parental lines for crossing program SSR markers have used, and to study the extent of heterosis in combining ability for the yield and other quality traits, and in nature they found out the nature of gene actions with respect to these different traits in the study. Based on this molecular marker study, they have just grouped some of the lines which is totally really diverse, which are utilized for the for the hybridization program, and they have evaluated some of the hybrids which is really giving the good results with respect to the yield power, that is specific combinability for the yield and other parameters, also for different biochemical traits. Optimizations also done in this case of seed productions, particularly in case of garden pea, that is variety they have taken Pusa probal, and which is the recently released variety, which is best sown for the 24th November, and which can be recommended for dose of nitrogen with the, and foliar spray of about 2% at 60 days give the high yield seed productions about 21.9 quintal per hectare. In seed quality traits also superior in case of 9th November plant sowing, but the yield as par with the 24th November sowing. Another student, the Manjunath, is working on the cauliflower. It is also in the Cartine station, and he studied the morphological and molecular divergence among the cauliflower genotypes from different maturity groups, and to study the response of cauliflower genotypes also for the Xanthomonas compostis, that is RESH 1 and 4. He studied all the materials, and there are about 48 cauliflower genotypes he has taken, and about 160 essence primers which is used for the polymorphic survey in respect to this one. And based on these molecular markers, they have having 4 different groups, which is in case of cauliflowers, the genotypes is grouped there and clusters there, and which is utilized for the breeding program. Also, they have screened up against this RESH1 and RESH2, 4 with respect to with the different genotypes, and they screen based on the scoring system, and also found some of the genes which are susceptible to RESH1, but they are resistant to the RESH4, and some other susceptible to the resistant to the RESH1, but some partial resistant to the RESH4. So this is also found in case of different groups of this cauliflower. Another students also worked on this particularly in the okra, and he studied the evaluation of genetic diversity based on the morphological and molecular markers with respect to the, because the genome analysis already not been reported in Abelmastus esculentus, so many difficult to get the polymorphism with respect to the okra. Then estimations of heterosis and combining ability studies for the quality and YM resistance also found it here, and he is also having this constructed never joining methods and they grouped this 90 based on the 96 genes into 42 polymorphic SSR markers, and they also studied the morphological markers, morphological traits, about 7 traits they have taken, and with the 50 SSR markers they used for the study. Also the quality parameters like total carotenoids, ascorbic acid, sugar, total phenols, and cuprac values also found it in different genotypes. Also he studied some of these hybrid combinations where he was used for the reactions to the parents and hybrids, because in okra if you are not developing the hybrids, particularly for the resistance, it has no value, and that's why he have also screened some of the hybrids and is found in the and classified these hybrids in different categories with respect to resistance. In case of morphological and biochemical tests and the molecular characteristics in chili plasms also studied by one of the MSc student, and to characterize the genetic diversity selected in chili genotypes using molecular markers. He also sees the different exotic lines, which is variations with respect to fruit shape, fruit color, fruit positions, color, color, ripened fruit color, etc. And also they estimated the capsaicin and capsaicin, which is really good for the human health point of view, and also the molecular marker analysis also done with respect to the different genotypes. Janani worked on particularly for the carrot, particularly he has used 19 genotypes, which is in the and cross about 90 crosses he did it with the line tester methods, and he evaluated many of these hybrids which respect to the root weight, core diameter, harvest index, and root yield are having different hybrids, and waste 3 hybrids is mentioned here, and also based on the quality parameter also we have classified the hybrids with respect to different categories itself, and these are the prominent hybrid combinations with very very narrow core thickness will be there. Now coming to this another students in the brinjal, he got also presented for the IARI merit medal, he also selected for that one. The Santhia is really working very hard with his field aspect to this heat stress in case of morphological characterization of the done based on the yield traits, physiological parameters like RWC, chlorophyll content, membrane index, the stability index, canopy temperatures have been measured, and also he also found some biochemical analysis with respect to antioxidants and proline itself. So these are the some of the findings here what is obtained here. DBL21, that is Dhala Chotla local, in Pansamrat, which is found to be high, tolerant to the high temperature, and these are also mostly utilized for our breeding program, particularly for the hybrid development. And the students working on the bitter gourd in the post-harvest technology with Ashwini, he's worked with Dr. Avni Singh in case of protected structures. When we get it, the fruits outside, it will remain only 1 or 2 days. So that's why we need to have some post-harvest structure, post-harvest physiochemical changes with respect to the different harvesting stages. Also, we use some of the edible coating and zinc raking for the storage and quality of this bitter gourd. And you have changed in the chlorophyll content when you go for this one as to the storage in the normal conditions. And The changes of saponin charantin also with respect to the days, if you consider, there will be in case of saponin content will be more in the 20 days after pollinations, and charantin also after 16 days of pollinations you have maximum amount of charantin. After that there will be degradations of these materials, and we also utilize the edible coating for 6 days of the storage, and we found a significant effect on the edible coating, particularly the guar gum coating, which is it is also done in this case. So this is also you can see in the storage conditions, both in the ambient conditions as well as the controlled atmosphere storage. So these are these publications 33, and we have more than 17 is more than 6 is 17 publications, and less 5 to 6 is 16 publications, and the honors and awards we have received some of the all the faculty members, many of the faculty members have received the different awards. The foreign training deputations also, Anil went to this international symposium in Allium, and Binoy went to Japan for the NIAP training program from 6 December to 29th February 2020. And these are the students' participations, particularly for the different events, and they got gold medal, silver medal also. We must congratulate them because of their hard work. And also we have exposure visit to the PG students to the Palampur, and from 6th October to 12th October this time. And 11 students from divisions are recommended for receive the financial support from NHP CAST program, and 2 PhD students selected for the dual degree program at Australia and pursuing their research program in WSU Australia. So thank you to director of this institute, joint directors, associate dean, head of the divisions, and faculty. Thank you to all.
Thanks, Dr. Behra, for your well presentation. Very good, excellent. I think we have finished our presentations from the 4 divisions of School of Horticulture Science, and many thanks to everybody, because just I want to give some few remarks, because most of the chairmen have covered lot of good advices and remarks they made for the concerned schools. And regarding IARI is concerned, because because this is a premier institute, no doubt they are having excellent faculty, and also the cream of students they come and also study here. Ultimately they do excellent research as comparison to other ICAR institutes, I can say, as well as state agriculture universities and also central agriculture, because I visit most of the institutes, because I covered the chairman of the QRT and RSC, most of the ICAR horticulture institutes during last 20 years, including I also visit as a chairman of NAC committees and also peer review committees for central agriculture universities and also central universities and also state agriculture universities. So we know what research is going on in everywhere throughout the country since last 5 decades, because I am associated with teaching, research and extension since last 5 decades, especially in horticulture. And so, and also I was associate lastly in IRA also QRT, because Dr. Punjab Singh was the chairman. I was a member along with Anupam Verma and S.A. Patil and Mr. Dr. Joshi and all other. We visited most of the research stations, regional stations of IRA. All the regional stations I visited along with our Honorable Chairman Dr. Punjab Singh, and really the work which is going on are very excellent, and for that reason actually I am very happy to be here today and to chair this session for the School of Horticulture. And because all the divisions, when we visited and during the QRT visit, it was excellent, including our director. My congratulations to him. He is having a very good, lot of contribution, good contribution in the breeding aspect in the rice. And for that reason, because not only crop improvement, crop production and crop protection and post-harvest technology and basic sciences, lot of contribution at IRA. There is no compromise with other thing. And regarding actually, because this good number of varieties as regards horticulture is a concern, because I am associated with IRA since last 70s, because a lot of varieties in the fruits during those days, the Amarpalli, Mallika, whatever it was released by Dr. R.N. Singh, Dr. S.K. Mukherjee and Dr. P.K. Mazumdar. And those varieties are coming up well, because they are much popularized now in the different states, commercially grown, adopted. But whatever the varieties now it is released, either by the IRI, no doubt good hybrids have been developed, by IHR as well as Lucknow, our Institute of Subtropical Fruits. And ultimately they are not coming to the field. That is a concern, because we should be very serious, because no doubt we developed good varieties, but that should be commercialized and come to the field. That is, we should take through the KVKs, because we are having a 717 KVKs now, because I am also now the member of the RSE for the Ataris, 11 Ataris. What we review, that our varieties, whatever we are developing in fruits as well as vegetables, and and also floriculture, that should come to the farmers field. That is more important. And regarding the fruit science is a concern, because the crop improvement side, actually work is not going on well in the present years as comparison to previous years, because it's a long duration work. So people generally they prefer to work on research in vegetable crops, floriculture, and also post-harvest. Food crops generally now, most of, not only this institute and most of the ICAR institutes, those are dealing with NRCs and IHR and all these things. And the way the scientists were involved in 60s, 70s, 80s, not now in 2000. That is actually, we should give a much emphasis for the fruit research. As come, no doubt vegetable and floriculture, we have done excellent work, because I was also a chairman of RSE floriculture, orchids, and also now also presently I am the chairman of QRT for vegetables also. And no doubt IAVR and IHR and including IRA, they are doing a very excellent job in vegetables. They have got a number of good varieties. But mainly the seed industries again, because the private seed industry they dominate. Because our public varieties, they are not coming. Just always I say in most of the meetings in horticulture that we should see that our hybrids and our improved types, they should come to the field. Because you know the IRA also, because the Pusa ruby steel, it was released by the Dr. Chaudhary and others in 1960s, and still it is a popular in Eastern India. People want to grow Pusa ruby tomato, even okra, Pusa savani, and lot of varieties are there, but people still want, they are so popularized. And for that reason, we should give importance, because our public varieties and ultimately hybrids and other thing, whatever we are having, and we should see that that should come to the field. And regarding, because you know always we speak when we go to the field and everywhere and anywhere, because we always think since last 50 years or 60 years when the research was started in horticulture, we talk of rootstocks, we talk of bearing pattern, irregular bearing and regular bearing, high density, seeds, planting material, because that is a continuous process. For that reason we should produce, because in a vegetable seed and ornamental, again you know the government of India gives lot of Indian. We produce by the ICAR institutes as well as state agriculture universities as per the Indian, and also by IRA and other. But thing is that when it is not disposed, because for cereals and pulses, for other consumable goods, no problem, because that can be sold as non-seed and for consumption purpose and all. But these vegetables are very costly, and ornamentals also, seeds, whatever seeds we produce, that should be disposed. That is more important, because you know, because most of the breeder seeds when we review in ICAR institutes as well as different universities, ultimately the breeder seeds when it is not disposed, they dispose as a TL seeds, truthful level. Again, for that reason it is a big problem. Whatever the money we spend, we don't get, because we should get under revolving fund. Ultimately we spend money, and we should increase also our generation, our fund generation and all these things. And floriculture, and for another thing also regarding the transfer of technology, because whatever the technology we developed, we are having a new technology numerous, because we are having a lot of technology developed with the ICAR institutes, central universities, IRA, and no doubt, because but that is not going to the much to the field, because again the extension, we just created more than 717 KVKs, no doubt they are responsible. But the state machineries and central government, ultimately they always blame the universities as well as ICAR institute, the technology they are not transferred. How we, because the extension machinery is with the state government, ultimately that should go to. And another also regarding because the horticulture, mainly vegetables as well as the floriculture or fruits, but they are very perishable in nature, because unlike other cereals and pulses. For that reason we should give a more emphasis for the cold chain. That is no doubt, because we are doing some work, because most of the ICAR institute, they go produce a lot of these post-harvest products, but most of the things are not commercialized. That is a big problem. we should see that they should be commercialized. And also, because when I was the chairman for the 12th plan, our horticulture group, I was the working group, and we have given much emphasis for the post-harvest, value chain, transport, godams and other things. But the total money was sanctioned, but ultimately still it is a necessary to give more emphasis for this transport for getting the better marketing and also better price by the farmers. And also regarding the vegetables are concerned, and most of the perishable, they are now post-harvest, for increasing post-harvest life, they are treated with the chemicals. That is again, if you go for the residue analysis, most of the vegetables, if you test, ultimately 100%, 99 to 100% are, you are having the residue of chemicals and insecticide. For that reason, nowadays lot of people, they suffer for different diseases and all these things, different disorders. For that reason, and also we should be very careful for that. And for that reason, and also protected cultivation, that is also most important, and organic farming, that is also, because again organic farming, when we think of, if you think of the population, ultimately we don't have much of farmer manure, biofertilizers and biopesticides and all these things, but again it is a problem. But for healthier, because you know the olden days, whatever the vegetables we are going, real aroma we are getting, real taste we are getting. No doubt we are having good hybrids, we are producing more, it is a good for the production side and also to meet the requirement of the people. But we should see also other side also, the real taste also should come with the hybrids, real taste, real aroma for getting. And I think these are the few, because I don't want to take much time, because already I think it is going to 8:30 and our Honorable Director is sitting and also Dean is sitting from the still morning, and also convener, and my thanks to Director Dr. Singh and Dr. Rasmi Agrawal ji, Dean, and also Dr. Meera Singh, convener. And also I am very thanks to the audience, at least they are still sitting from morning till now 8:30 p.m. Thank you all.
Thank you very much, sir, for your visionary and path-guiding remarks, and under the able guidance of our Honorable Director, definitely these concerns will be addressed. I request Honorable Director IARI, Dr. A.K. Singh, and Joint Director Education, Dr. Rashmi Agarwal, to kindly facilitate the estimate chair of this session as a token of love and appreciation, the memento and shawl.
So before that, I must say that the presentation made by Dr. Behra, it was all full of good science, and I congratulate all the students whose work has been presented. I don't see Dr. Tomar here, he is not here. Dr. V.R. Sagar, you are there, okay. So I wish Dr. Tomar was here to witness. I don't know what is the compelling reason that he is not here. As head of the division, he should be present here. And this kind of research work should also be highlighted when we have our presentation of a school coordinator report. Hardly this gets reflected in terms of good quality science that is being done. Okay, so please take care of this and try to strengthen this line of work. Very good work. Keep it up. Thank you very much.
I now request the convener of this session, Professor Neera Singh, for the formal vote of thanks.
My sincere thanks to Professor Devpere for timely completing the session and for his critical comments and the crisp summation of the findings of all the students which their professor have presented in this session. And I'm sure that all of your suggestion will be taken care by the professors and head of these divisions. And I sincerely thank our director sir who has devoted so much time today. He was here most of the time. Thank you very much, sir. And similarly, Dean Madam, who is constantly supervising all the proceedings here, and I thankful to her for successful completion of 5 schools today. I thank all the professors who have presented the finding of the student, all the 5 schools, and sincerely thank all the heads of the division, professors, dear students, for patiently listening to all the presentations today. Thank you very much, and I thank all the stage management, the PG school, and audio-visual persons who are handling all these activities. Thank you very much. And now we disperse now after completing a very long day, and I request you all to be present at 9:30 tomorrow, because we have to finish it in time to start with the award lectures at 11 o'clock. Thank you very much. Good night.
I think thanks to everybody, including our honorable director as well as dean and convener. Thanks to all.